Imagine a world where gravity, this invisible force that holds everything together, was cut in half. Planes would glide slower, oceans would behave strangely, and our daily lives would never be the same. But how would such a change impact our planet, our bodies, and even life itself? Let's dive deep into this mind-bending scenario and explore the fascinating consequences of having Earth's gravity. Gravity is the force that pulls two objects toward each other. It's why apples fall to the ground, why we stay firmly planted on Earth, and why the moon orbits our planet. This force is proportional to the masses of the objects and inversely proportional to the square of the distance between them. In simple terms, more mass equals more gravity. Earth's gravity depends on its mass and the distance from its center. On the surface, the acceleration due to gravity is approximately 9.8 meters per second squared. This force is precisely calibrated to keep us grounded, yet light enough to allow movement and life to thrive. Gravity isn't just about keeping us on the ground. It shapes planets, stars, and galaxies. It influences the tides, drives weather patterns, and even helps define the passage of time and space. Without gravity, life as we know it wouldn't exist. With gravity halved, you'd weigh only half as much as you do now. This would make daily activities like walking feel effortless. You could jump twice as high and lift objects with far greater ease. Imagine basketball games with players soaring several meters into the air, or toddlers leaping like superheroes. Dropped objects would fall more slowly, resembling slow motion. While this might seem amusing, it would drastically alter safety measures. Parachutes would take longer to deploy effectively, and even something as simple as a drop phone could take seconds to reach the ground. Vehicles, planes, and trains would behave differently. Airplanes would require less lift to stay aloft, but might lose stability in turbulent conditions. Cars might need entirely new suspension systems to accommodate weaker gravitational forces. Skyscrapers, bridges, and other structures are designed with current gravity in mind. With halved gravity, the distribution of stress and weight would change. Tall buildings might sway more in winds, and bridges could face unexpected challenges, potentially leading to catastrophic failures. Gravity keeps oceans in place and drives tidal movements. With halved gravity, water would behave chaotically. Waves would grow higher but slower, and tides would weaken. Coastal cities could face devastating flooding, while marine ecosystems would struggle to adapt to these new conditions. Earth's atmosphere is held in place by gravity. A weaker gravitational pull would cause it to expand outward, thinning the air near the surface. Weather patterns would shift drastically, with storms behaving unpredictably and winds becoming slower. Aviation and meteorology would have to adapt to this altered environment. Gravity plays a role in maintaining the balance of forces beneath Earth's crust. With halved gravity, tectonic activity could slow down, leading to fewer earthquakes and volcanic eruptions. While this might sound like a relief, it could also disrupt the planet's natural recycling of carbon and minerals, essential for long-term climate stability. The moon's orbit is governed by Earth's gravity. A weaker pull could cause the moon to drift farther away, destabilizing tides and potentially altering Earth's axial tilt. This tilt governs our seasons, so any change could have profound impacts on global climates. Without the constant pull of full gravity, muscles and bones would weaken over time. Similar to astronauts in space, humans would need rigorous exercise routines to prevent atrophy. Everyday tasks would require less effort, but our bodies would pay the price in the long term. With less compression on our spines, people might grow taller. Over generations, humans could evolve longer limbs and thinner frames to adapt to weaker gravity. This could lead to a species that looks vastly different from today's humans. Weaker gravity could lead to blood circulation problems, as the heart wouldn't need to work as hard. Lung efficiency might decrease, and fluid distribution in the body could feel floaty, similar to what astronauts experience in microgravity. If gravity remained halved for thousands or millions of years, life on Earth would evolve to adapt. Trees and plants might grow taller and thinner without gravity pulling them down. Root systems would spread wider to maintain stability in the weaker gravitational field. Photosynthesis processes might also adapt to changes in atmospheric thickness. Animals would likely develop lighter, more agile bodies. Birds might struggle to fly as reduced gravity changes air pressure dynamics. Over time, entirely new species could emerge, taking advantage of the altered conditions. Future humans might look unrecognizable. Lighter frames, larger eyes for better vision in thinner atmospheres, and even new ways of locomotion could emerge. Societies might develop technologies to simulate artificial gravity in key environments, preserving traditional human physiology. While Earth's orbit around the sun wouldn't be immediately affected, a weaker gravitational pull might make the planet more susceptible to external forces, such as passing asteroids or gravitational interactions with other celestial bodies. Earth's core relies on gravity to generate the magnetic field that protects us from harmful solar radiation. A weaker core could destabilize this field, leaving Earth exposed to intense solar winds. Over millions of years, a halved gravitational force might struggle to hold the atmosphere or surface materials in place. Earth's environment could degrade into something resembling Mars, barren, with a thin atmosphere and no protective magnetic field. Having gravity is a fascinating thought experiment that reveals just how perfectly balanced our planet truly is. From the way we move to the way life thrives, gravity is the invisible glue holding it all together. The next time you feel the weight of the world, literally remember, it's the perfect weight for life as we know it. Thanks for exploring this alternate reality with me. If you're as fascinated by the what-ifs of science as I am, don't forget to like, subscribe, and hit that bell for more mind-bending content. Until next time, stay curious.